Today we're going to talk about the equidistance theorems. But before we get to those theorems, we're going to talk about a couple of definitions and postulates. The first postulate we're going to talk about is that a line segment is the shortest path between 2 points. This may be something you've heard before in a previous math class such as algebra or maybe even back in middle school. The first definition that we have is a perpendicular bisector, and you may remember this in the last video, in the last example. To be a perpendicular bisector of a segment is when the line creates two congruent segments, but is also perpendicular, meaning it creates 90-degree angles. Let's look at that example from the last video. We're given the following. Line segment MP is congruent to line segment NP, and line segment MS is congruent to line segment NS. And that diagram is shown on the right. And what we did in this example is we kind of did a detour. What we first did is we started with getting those larger triangles congruent. And that allowed us to get some angles congruent, which then allowed us to move to the smaller triangles being congruent, which has allowed us to do the angles and the segments congruent. Again, you can look back in your notes to show what those steps were previously to get to our conclusion. As you can see, we took quite a few steps. We had 11 steps in total to get from our given to the actual conclusion, that the line itself is a perpendicular bisector to the line segment. Well, what theorem 24 says, or one of the equidistance theorems says, is that if we have 2 points that are equidistant from the endpoints of a segment, then the 2 points determine the perpendicular bisector of that segment. So what does this mean? Well, it means that if I have a segment and I have 2 points, and I know that these 2 points are equidistant, meaning that this side is congruent to that, and then this side congruent to this side, then the line drawn through the 2 points, if I can get it through the 2 points, is indeed going to be a perpendicular bisector to that line segment. Meaning, I do not need to do 11 steps to get to my perpendicular bisector. If I know 2 congruent line segments, or 2 congruent points to a line segment, I can just directly go to the perpendicular bisector. So this is one diagram of what that would look like. Another would be, same situation, you have a line segment, you have 1 point in which is equidistant. Pretend that these are congruent to the endpoints of the segment, but it could also be in here, where these segments are congruent. Again, the perpendicular bisector would be the line going through those 2 points. It would create congruency here and here, but also create right angles there. One last diagram you might see this in is if I have a straight line. Let's say that we have a point down here, congruent to both sides. The other point can be directly on the line. the line going through it, again, pretend this is a little bit more even, creates the perpendicular bisector of them. Now, kind of the inverse of this is Theorem 25. If a point is on the perpendicular bisector of the segment, then it is equidistant from the endpoints of that segment. So, if CD is a perpendicular bisector of AB, then that means that any point on DC will be congruent to the points. So I can put a point here, it would be congruent to A and congruent to B. I could put a point here, and then to the endpoints it's also congruent. It could be way up here. So any point that I place, if I know that CD is a perpendicular bisector, then I know that its distance to the endpoints will be congruent. So again, let's look at that example. Given MP is congruent to NP, MS congruent to NS, we want to prove that line PS is a perpendicular bisector of MN. Well, since I know that MP is congruent to NP, and MS is congruent to NS, based on Theorem 24, if 2 points, meaning P and S, are equidistant from the endpoints of the segment, the endpoints being M and N, then the 2 points determine the perpendicular bisector of that segment. Meaning, I've established that they're equidistant, therefore I don't need to do any more steps if I have those congruent. And I can go right to the conclusion of line PS is a perpendicular bisector of MN, based on Theorem 24. And our 11-step proof now has become a 2-step proof.